Hello Year 12 and welcome to this, our first video for our next topic, which is the normal distribution. We're looking at statistics again, and in our last topic the statistics we were looking at were bivariate data, right? They were sort of scores that had two attributes. That might have been like your height and your arm span, right, for each individual person. And that was a new thing and a complicated sort of a thing. This time we're going back to univariate data. Now this might be a data set like your score in a test, right? And I collect the scores for lots of people. Now I'm choosing that example because score is the language that we use here when we're talking about each of those data points. We're talking about the score, what we've measured, and more often than not this is a measured value rather than a counted value. So test scores don't fit as well there because test scores are counted. Right, because test scores are discrete data and we are mostly looking at continuous, things that are measured, things that have units like meters or kilograms or something like that. However, it doesn't really matter whether it's discrete or continuous. We are looking at this thing called a normal distribution, which is a pattern of distribution, right? A pattern of how the scores are spread out. Right. This pattern is a very common pattern, this normal distribution. Sometimes it's called a bell curve, right, or a normal curve, because it has this sort of bump in the middle and flat out near the edges. And what that really tells us is that we get a lot of scores near the middle and not many scores out near the edges. That doesn't seem terribly unlikely. We have a bit of a graph here, and what this is really, we should have two axes here. We never draw it with two axes, but this axis here, my horizontal axis, which would typically be our on a typical graph would be our independent variable, is our score, right? That's our score, and we've really got some sort of vertical axis here which is our frequency. Okay, so any point on this curve, say this point here, tells me that this score here, whatever that represents along that axis, this score occurred this many times. That's really what the shape of that curve means. And so the most common score is this one right here in the middle. Right, the most common score is the mode. Right, that's what the most common score is. That's what the mode means. The most common score, the score with highest frequency. And this little symbol here we should be familiar with. An X with a bar over the top means the mean, right? The average. You add all the scores together, divide it by how many scores you've got. So in a normal distribution, our mean is also our mode, and looking at the symmetry of it, we should be able to observe that it's also the median. Okay, the middle score. So we need to learn some specific details about this pattern, about this distribution that's called a normal distribution. This tells us that from one standard if I have a mean and a certain standard deviation, let's say my mean is 50 and my standard deviation is 10, then 34% of scores would be between 50 and 60, right? Between the mean and one standard deviation above the mean. 34% of scores, about 1/3 of all scores in a normal distribution, or in normally distributed data, about 1/3 of all scores fall within the mean, between the mean and one standard deviation above the mean, and equally between the mean and one standard deviation below. So this here, from one standard deviation below to one standard deviation above, right? Again, if we use that example of a mean of 50, standard deviation of 10, then typically we would expect there about 2/3 of all people to get a score between 40 and 60. Right? I say 2/3, this empirical rule that we use that's been sort of calculated by someone else some other time, is we're actually going to say 68% of scores fall within that range, from one standard deviation below to one standard deviation above. If I double that range to 2 standard deviations below to 2 standard deviations above, I couldn't double the number of scores because we've already used up about 2/3 of the scores. Right? When I double the range, right, those parts outside of my original range of 1 standard deviation below and above, right, scores out here are less common. Right? These are less common or less frequent. So if I take in this 4 standard deviation range from 2 below to 2 above, right, that encompasses a total of 95%, and I could work out this number here from that. Right? If all of this is 95 and this part is 68, right, if I take 68 away from 95, then I'm left with 27. And because it's symmetrical, then half of 27 over here is 13.5, and the other half of the 27, the other 13.5, falls over here. So that's where the 13.5 comes from. Our next measurement, and in fact our sort of final figure here, is if I go all the way out to 3 standard deviations below and above, right, that's going quite a way now. If we're back to our mean of 50, standard deviation of 10, then we would be looking at from 20 to 80. Over that range of scores, 99.7% of all scores typically fall within that range. Right, so that's only 3 out of 1,000 fall outside of that range. And again, as before, if I take my 99.7%, subtract my 95%, leaves me with 4.7%, and half of 4.7 is 2.35. So in this little part of the curve here, right, from 3 below to 2 below, I expect 2.35% of all scores. Now, these numbers here are now kindly given to you on your reference sheet. You need to be very familiar with them, but you don't have to remember them off by heart because they will be on your reference sheet. Okay, but that's really what we're introducing in this first exercise, is the idea of this normal distribution and how many percentage, or what percentage of scores we expect as we move away from the mean. So here we go. We've got an example. We've got a large group of adults are normally distributed, so I can use this empirical rule. Mean of 170, right, so that's my mean of 170, and a standard deviation, right. Now I'm going to use an S here, but sometimes we use this symbol too. There's a subtle distinction between them, we'll talk about it another time. Okay, let's use the S this time. S equals 8. So, it's perfectly fine when you get your HSC exam or any other assessment to use a highlighter or a pen or a pencil to circle things, underline them here like this, put annotations on there. That's a good part of your working. Anyway, so first question, what percentage of the heights lie between this and this? Now the best thing to do here, I would very strongly recommend when you do these questions, is draw your curve straight away. Doesn't have to be perfect, right, but I'm going to split that up here. That's 1 standard deviation either side, 2 standard deviations either side, 3 standard deviations either side. Now I know my mean is 170, right, my standard deviations are 8, so that's 178, 186, and 194 there. And now going backwards, 162, 154, and 146. Right, mean standard deviations of 8. So, oh, and I should also write in here 34, 13.5, 2.35, and 0.15. Now I just remember those because I've done these questions before. And you should, by the time you approach your HSC and you've practiced enough of these, probably remember these numbers without referring to your reference sheet. But to begin with, right, scroll up, have a look. Right, use that as your reference. It's part of answering these questions. Ooh, I missed one in there. There we go. There's my percentages and my scores. Right, with that little diagram done, answering these questions are fairly straightforward. So, what percentage lie between 162 and 178? 162, 178 is 34 plus 34. 68%. Nice. More than 178. Here's my 178. So I want these ones here this time. It's 13.5 plus 2.35 plus 0.15. What's that equal? Well, this is 2.5. I think that must be 16%. Have I got that right? I think I have. There we go, 16% greater than 178 centimetres. Now, if a random sample, right, of this data set has 6,000 adults, how many have a height between 146 and 194? We're complicating it a little bit, but not too much. 146, right, from here this time. Let's get rid of this one so we don't. 146 to 194. And that's from here to here. Now I could add those together, or in fact I can see that's my 99.7. So I want 99.7% of 6,000. Rightio, so 99.7% of 6,000, here's my trusty calculator. 6,000 times 0.997. Oops, too many. 0.997. Right, here we go. Equals, now I'm expecting the answer here of, 5,900 and things. 5,982. So out of those 6,000 people, I would expect 5,982 of them to have a height between 146 and 194. Very good. Now, between 162 and 186, let's come back up to our little sketch here. 162 and 186. Let me get rid of that little bit. 162, that's here. 186 is here. Right. Now, this is a little asymmetric. You see, because it's not sort of centered around the middle of the curve. So I've got 34, 34, and 13.5. Right. Let's see. 68% plus 13.5% equals, what's that, 81.5%. And 81.5% of 6,000 is equal to, back to my calculator. Come on, calculator. Here it is. Clear that one off. Now, 0.815 times 6,000. Now, common sense tells us that we're looking at, again, a bit over 5,000. Oh, wait, 4,890, close enough. 4,890 people. Rightio, that's how we use the empirical rule to estimate the number of scores within a certain range. Okay, there's a bit to take in here, but remember, you do get some assistance with this on your reference sheet. Okay, that's it for our first video. Hope you enjoyed. See you in class.